Good afternoon, friends and my dear children. A very good afternoon to all of you. So today we are going to learn about factors affecting ionization energy. Up to now I have uploaded the videos even regarding periodic properties also. Periodic properties is a topic which I have started very shortly. Okay, so please go through the videos. Those who are watching my channel for the first time, request all of you to please kindly watch the videos and please leave a like, a comment, a suggestion, and if you haven't subscribed my channel yet, please don't forget to subscribe my channel and please pass the information to all of your friends and your family members so that if you are into my channel, you are into a right way in search of a very good information regarding chemistry subject. Okay, so this is your Lalita Peri ma'am. Okay, so today we are going to learn about factors affecting ionization energy. Okay, so this is one of the topics which we have to discuss in periodic classification of elements, right? So today's topic is what? Factors affecting ionization energy. Factors affecting ionization energy. This is the topic for today. So we have learned what is meant by ionization energy. The energy required to remove an electron from the valence shell of a neutral gaseous isolated atom. You call it as what? Ionization energy, right? So we have learned about ionization energy and how it varies in groups and periods, that we have learned, right? So here today we are going to learn about factors. What are the different factors which affect the ionization energy? Okay, so let us learn that, right? So factors, first one is atomic radius, means size of the atom. Okay, already we have learnt this. If the size of the atom is more, okay, it is easy for us to remove an electron from the valence shell of an atom. Okay, influence of nucleus will be very less. Okay, so here atomic radius plays a very important role. Okay, if atomic radius increases, ionization energy decreases. Means it is easy for us to remove electron. We need not to supply much energy if it is for a large atom. Why it is like that? If it is a large atom, influence of nucleus is very less, isn't it or not? As the distance is increasing from nucleus to last orbit. Okay, as the distance is increasing from nucleus to last orbit, okay, the nuclear charge decreases. So if nuclear charge decreases, it is very easy for us to take out the electron. We need not to supply much energy there. So if atomic radius increases, I just kept an upward arrow, please understand, increases. If atomic radius increases, ionization energy decreases. Okay, so this is the first factor, okay, which influences what? Ionization energy. Okay, now second one is what? And in this itself I have told. Second one is nuclear charge. Second one is nuclear charge. As just now I told you, for small atoms, if the size is very less, nuclear charge will be very high. If nuclear charge is more, then that particular electron will be under the influence of nucleus and it cannot be removed easily. Okay, so if nuclear charge increases, what happens? Ionization energy also increases. Okay, in order to overcome the influence of nucleus, okay, we have to supply lot much energy to remove that electron. So if nuclear charge increases, what happens? If nuclear charge increases, ionization energy also increases. Okay, now ionization energy also increases. If nuclear charge increases means what? Size will be very less, isn't it or not? Size is very less, only very small atom if it is there, then only influence of nucleus will be very high. Okay, on this last orbit electrons, influence of nucleus will be very high. So to get away from the influence of nucleus means you need to supply lot much energy. Then automatically what happens? Ionization energy increases. Okay, so if nuclear charge increases, ionization energy also increases. Okay, now coming to the third factor, a very important factor. Okay, what is that third factor? Screening effect. Screening effect or shielding effect. Okay, now screening effect or shielding effect. Okay, sometimes they may give only this topic, I mean this definition they'll ask you to write what is screening effect or define screening effect or shielding effect. So what is screening effect? Okay, so let us learn about that. This is one phenomenon in which if the number of inner shell electrons are increasing, okay, then nucleus cannot able to focus on the last orbit electron. Okay, if the number of inner electrons are increasing, okay, the phenomenon in which the number of inner electrons, if the number of inner electrons are more, okay, if the number of inner electrons are more, then nucleus cannot effectively focus on to what? Last orbit. Okay, nucleus cannot focus on last orbit because here these inner electrons are acting as what? Screens or shields. Okay, they are objecting. In other words, what we can say is they are objecting. So that what happens? The influence of nucleus, the focus of nucleus on the last orbit electron decreases. Okay, so if it decreases, nuclear charge decreases. If nuclear charge decreases, it is easy for us to remove this electron. Isn't it or not? It is now not under the influence of nucleus. Why it cannot be under the influence of nucleus? Because there is lot much traffic jam is there here. Okay, now traffic jam means what? Inner shell electrons are acting as screens or they are acting as objections. Okay, so that nucleus cannot clearly focus on last orbit electron. So if nucleus cannot able to focus on last orbit electron, nicely this electron escapes out. Isn't it or not? Teacher is, it is like a classroom situation. If teacher is standing near to the board, okay, to explain on the board, teacher stands near to the board. If the child who is sitting in the last bench, okay, is making any kind of noise, suppose, okay, and if entrance is there or exit is there from that side, nicely, without being noticed by the teacher, he can escape out of the class. Isn't it or not? Sometimes it happens. Okay, it did not happen with me, of course. Okay, because the classrooms are not so big. Okay, so, and if they are big also, two entrances are there. Okay, so that they'll never go away from the influence of teacher. So here teacher is like a nucleus and last orbit child, I mean last bench child is like a electron. If number of children who are sitting in the middle benches are more, okay, teacher cannot focus on last orbit. I mean to say teacher cannot focus on last bench child. Okay, then what happens? The influence, the grip of nucleus on the last orbit electron decreases. So nuclear charge decreases. So if nuclear charge decreases, what happens? It will become very easy for this last orbit electron to come out. Okay, so much energy not required. Okay, so that phenomenon of decrease in the nuclear charge because inner shell electrons act as what? Screens. That phenomenon you call it as what? Screening effect. Okay, so sometimes they may ask this as a 2 marks question. So please remember the phenomenon in which we notice, what we notice? Decrease in nuclear charge. We notice what? Decrease in nuclear charge. We notice decrease in nuclear charge. Okay, because inner shell electrons act as shields. Because inner shell electrons act as what? Act as screens. inner shell electrons act as screens or shields so that nucleus cannot focus on last orbit electrons. Nucleus cannot focus. Okay, now nucleus cannot focus on whom? On valence electrons. Okay, now nucleus cannot focus on valence electrons. So valence electrons will enjoy, masti for them. Okay, they are not under the influence of nucleus, so they can easily escape out of the atom. Okay, so such phenomenon you call it as what? Screening effect or shielding effect. So if screening effect is more, okay, objections are more, so automatically ionization energy decreases. Isn't it? Much energy you need not to supply because influence of nucleus is not catching hold of that last orbit electron. Nicely that last orbit electron escapes out. That phenomenon you call it as what? Screening effect. So if screening effect increases, what happens? If screening effect increases, okay, if screening effect increases, nuclear charge decreases. Isn't it or not? Nuclear charge decreases. So ionization energy also decreases. Isn't it or not? Downward arrow, upward arrow I am keeping. Please check. It is for increase or upward arrow is for increase. Downward arrow is for decrease. Okay. So this is regarding the third factor. What is that? Shielding effect or screening effect. Right. Now coming to fourth factor. Fourth factor is penetration power. Fourth factor is what? Penetration power. Penetration power. So what is penetration power? Okay. Penetration means what? Going deep into something. You call it as penetrate. To penetrate means what? Going deep into something. Here going deep into an atom. Okay. So here you all have learnt about orbitals. Isn't it? Orbitals or subshells. Okay. So in that you might have noticed that S subshell starts from first orbit itself. Isn't it or not? We have 4 subshells are there. Just recall about subshells. 4 subshells S, P, D and F. S subshell starts from what? First orbit itself. 1s can exist. P subshell starts from second orbit. In first orbit, P subshell won't be there. So P starts from second P only, 2P only. Similarly, D starts from third shell. That is 3D only. 1D, 2D won't exist. Okay. Similarly, fourth orbit, F shell starts from fourth orbit. That means who is very nearer to the nucleus? Once understand carefully. Who is very nearer to the nucleus? S subshell. Isn't it or not? Please understand the point carefully. Penetrate. Who is more deeply penetrated inside the atom? S subshell only. Because it can start from first orbit itself. 1s. Means who is very nearer to the nucleus? S is very nearer to the nucleus. Isn't it or not? Then comes 2P. Then comes 3D. Then comes 4F. So whose penetration power is more? Okay, now please understand carefully. S subshell is penetrated deep. He is penetrated deep inside the atom. Okay, now deep inside the atom. S subshell is penetrated deep inside the atom. That means very nearer to the nucleus. Isn't it or not? So if S subshell is, because it is very nearer to the nucleus, okay, the influence of nucleus will be more on whom? It will be more on S subshell only. Okay, so to remove electron from S subshell, is it easy? Or to remove electron from 4F subshell? 4F is very far from nucleus. Isn't it or not? So no problem at all. For 4F, electron can come out very easily because it is not at all under the influence of what? Nucleus. Very far from nucleus. Nucleus is here, 4F is somewhere here. Okay. Isn't it or not? But very nearer is whom? 1s is very nearer. Okay. So S is penetrated deep inside the atom. So So what happens? Penetration power of S subshell is greatest. Okay, now S subshell is penetrated deep inside the atom. Okay, so penetration power, if you speak for orbitals, penetration power of orbitals will have this order: S greater than, P greater than, D greater than F. Okay, these points you have to write in the exam. Okay, now, so S greater than, P greater than, D greater than F. That means penetration power for S is very high. That means it is very difficult to remove electron from S subshell in comparison with what? F subshell. You can take out electron easily from what? S subshell. A little energy is enough. But if you wanted to take out electron from S subshell, as because it is very nearer to the nucleus, lot much energy you need to give. Okay. So penetration power is one of the important factors which influences the ionization energy. Okay, ionization energy means what? How much energy which we need to supply to take out electron easily from an atom. Okay, so you cannot take out electron from S subshell because it is very nearer to the nucleus. Penetration is more for S and very less for F. So it's easy to take out electron from F and it is difficult to take out electron from S because its penetration power is more, right? So this is regarding fourth factor, penetration power. Okay, now coming to fifth one, right? Coming to fifth factor. What is fifth factor? Fifth one, half filled and completely filled subshells. Half filled and completely filled. Half filled and completely filled subshells. Okay, this is very important point. Fifth factor is what? Half filled and completely filled subshells. We have learnt certain examples that in some of the elements last orbits are being half filled, or in some elements they are completely filled. So half filled and completely filled orbitals, elements with half filled and completely filled orbitals are what? They are highly stable. Okay, now elements with half filled and completely filled subshells. Half filled and completely filled subshells. Okay, now half filled and completely filled subshells are what? Are very highly stable. Okay, now half filled and completely filled subshells are highly stable. Okay, so if they are highly stable, it's difficult to remove electron from such kind of stable orbits, isn't it or not? Like for example, yesterday we have learnt nitrogen. If you take, atomic number is 7, 1s2, 2s2, 2p, 3. Here P is half filled. Okay, now P is half filled. P's actual capacity is what? 6 electrons. But here exactly 3 are filled. So it is half filled. Half filled means difficult to take out electrons. Half filled means what? Highly stable. Okay, highly stable. If it is highly stable, it is difficult for us to remove electron from that half filled subshell. Okay, so IE is very high. Ionization energy is very high for such orbitals. Okay, suppose if you take completely filled. Completely filled is what? Neon. If you take neon, atomic number is 10. Inert gas, isn't it? So 1s2, 2s2, 2p6. Here P is totally, completely filled. P orbital's capacity is 6 electrons and all 6 electrons are tightly held inside the atom. Atom of what? Neon. Okay, so there is no place at all for movement also. Okay, so completely filled. That means it is highly stable. Okay, now completely filled. Completely filled means highly stable. So for such stable elements, it is difficult to remove electron from such elements. Okay, because of their high stability. Okay, ionization energy for such elements. Okay, now for such elements which are having what? With half filled and completely filled configurations. Okay, IE is very high. Half and completely filled configurations. Okay, now elements with completely filled or half filled configurations, okay, their ionization energy is very high for them. Okay, for such elements with half filled or completely filled configurations, ionization energy is very high. Isn't it or not? Very high ionization energy you need to supply. Otherwise, electron cannot come out of it. It don't want to come only because already it acquired stability. Okay, stability is the only factor which we require, isn't it, for the formation of bonds. If it is already stable, then why it want to lose electron? How can we remove electron? Very difficult. Okay, so half filled and completely filled orbitals, if they are there in any atom, for such elements, ionization energy will be very high. Okay, you cannot take out electron from them, right? So this is also one of the important factors. And next, last one, sixth one and last factor is what? Net charge on the ion. Net charge on the ion. So this is the sixth factor. Sixth factor, charge on the ion. Okay, so if charge on the ion increases, ionization energy also increases. Please remember this point and understand this point carefully. If charge on the ion increases, if charge on the ion increases, if charge on the ion increases, ionization energy also increases. Okay, like for example, you can take the example of aluminium. Best example you can take is what? Aluminium. Aluminium, you all know atomic number is what? 13. Okay, aluminium atomic number is 13. Right, children? Aluminium atomic number is 13. Okay, it's a, if you go for it's the nearest inert gas, neon, it is 10. So to become stable like neon, aluminium has to lose how many electrons? 3 electrons. It has to lose. Okay, all 3 electrons at a time, can it lose? No. So that's why we have learnt ionization energy IE1, IE2 and IE3. Okay, so first if you take a neutral atom of aluminium, first it loses 1 electron. Okay, now it loses 1 electron and forms what? Al plus ion. Unipositive ion, Al plus ion, and here the energy required, you call it as what? Delta H is, you are calling it with name IE1, isn't it? Similarly, from this unipositive ion, Al plus, okay, you are going to remove 1 more electron. More energy is required so that it transforms to Al plus 2, dipositive ion. Okay, here delta H required is called as what? IE2. And from this dipositive ion, from dipositive ion, 1 more electron is removed. 1 more electron. Then it transforms to Al plus 3. Isn't it or not? Then it transforms to Al plus 3. Okay. So, and that energy, you are calling it as IE3, third ionization energy. And we have learnt that third ionization energy is much more greater than second, and then second is much more greater than first. Okay. So, if one charge on the ion is increasing, ionization energy also increases. Isn't it or not? We have learnt that IE3 is much more greater than IE2, much more greater than IE1. Therefore, from this what we can conclude? If charge on the ion increases, see, to form Al plus, little energy is enough. To form Al plus 3, lot much energy is required. Isn't it or not? Okay. So, if charge on the ion increases, okay, if the charge on the ion increases, ionization energy also increases. Okay. Charge is increasing, plus 1 to plus 2, plus 2 to plus 3. If charge is increasing, ionization energy also increases. Okay, because to remove electron from neutral atom it is easy, but to remove electron from unipositive ion or from dipositive ion, difficult. Lot much energy is required. Lot much energy you need to supply for it. Okay, so until and unless you supply that much energy, aluminum cannot become stable. By losing 3 electrons, it has to lose how many? 3 electrons it has to lose to become stable like neon, isn't it? So that's why ionization energy also depends on the what? Net charge on the ion. Okay, so these are the different factors which influences what? Ionization energy. Okay, so up to here I am stopping this video because these are the 6 factors. Very important question. You can expect this question for 8 marks, or for sometimes they may give some questions like examples for half filled, completely filled they may ask, or example for charge on the ion, aluminum example you can take and you can explain. Like one factor also they may ask for 2 marks. Okay, that's why this topic of factors influencing ionization energy, that's a very important topic, and I request all of you to please go through the topic and write and practice. Okay, so thanks for watching all of you, and happy learning. Your hard work is your superpower. Okay, bye.